Hi everyone. I've had a couple of questions on how to do Lab 8. So I wanted to go ahead and kind of run through that quickly. Hopefully this will give you guys an idea of what I'm expecting. So the first part of this lab is looking at rotational collisions. And in this case, there are two disks, and one of them is being dropped onto the other. So we can go ahead and watch this video here. Okay, so you can notice that if I change it to slow motion, you notice that only the larger outer disc is spinning, and the inner one, which this person is going to drop, is not spinning, so it's stationary. Okay, so the idea is we have some moving object here with some angular velocity, and then we have this inner one that doesn't have an angular velocity, right? Because its velocity is 0. It's not moving. Okay. So the idea of the first part is to predict, after that collision there, what the final angular velocity is going to be of the entire system. Okay, so what you want to think about is, what we need to measure, what we need to find out in order to predict that final velocity. Okay, so if you remember our PowerPoint, we talked about collisions a little bit. Let me see if I can find my pages here. Let me see. My sketchbook. I think it was here that we were looking at collisions. Let's see. Yeah, so here in example 10.15, we looked at a collision, and it was, let me go ahead and zoom in here. Oops. It was a disc, and that disc strikes a stick. Okay, so that was our example. But here, in this case, we have a disc striking another disc. Okay, but it's the same idea of this collision with angular momentum. So you're going to be using some same ideas from that example. Okay, so when you're going through that, just think of what you will need to measure to predict that final angular speed. Okay, or that angular velocity. Okay, so again, think about the the angular momentum, how that's conserved, and so forth. That will be the main idea here. Okay, so take a look at that past lecture. I think it was the last one that I posted, and it should steer you in the right direction of how to make that prediction here. Okay, and again, you can select whichever trial. It says select the trial number that's closest to your birth month. If you don't want to do that, feel free to choose any trial. Okay, and then again, I want you to predict that final angular speed. Okay, and in the final part, you're going to test that prediction. Okay, so it's going to show you this video again. You want to make sure you select the same trial. It's going to show you that same video, but the entire thing. Okay, so I can show you an example. This is what it'll show you. Let me restart. It's going to show you the entire video here of that collision. So then you'll be able to take measurements and find that angular velocity. Okay, that final angular velocity. And if you're not sure how to start with that, you could use these tools over here. And remember that angular velocity is going to be something in units of radians per second. So we know that we're going to need to use some kind of angle and our timer here. Okay, so if I change this back to normal, okay, what I can do is I can watch these dots and see how far they go in terms of radians, so the angle, and then measure the amount of time that it took for it to cover that distance. Okay, so this one is kind of tricky just because it doesn't have the numbers on it, but just remember that we can look at a circle and we know that this is 0 degrees right here, and then going from there it would be about, let's see, this is cut into thirds. It would be 30 degrees, 60 degrees, 90 degrees, and so forth. Okay, remember 1/2 of a circle is 180 degrees. 1 whole circle is 360 degrees, 360. Or you could say that 1 whole circle is 2 pi radians. Okay, meaning that 1/2 of the circle is pi radians, and so forth. So you can go ahead and look up a unit circle, and it'll tell you exactly what these would be. Okay, so what you can do is you can follow one of these dots and figure out again how far it travels in X amount of time, and then calculate your velocity from that, your angular velocity. Okay, and so you would do the same thing for your after the collision here. Okay? Alright, so that is the idea of this part. I tried to kind of break it down to where it made a little more sense. I think the next one especially. So the next one, section 2, let me go ahead and bring that one up, is going to be a marble that collides with, first of all, block. Okay, so I can change my location of where it gets hit. It doesn't really matter. Just make sure that you, well, I guess it doesn't really matter which one you choose. The idea is the same here. So I can go ahead and press play to show you what you're looking at. So we've got a marble that gets shot at this block. Okay, and as it continues, that block goes flying in the other direction. Okay, and if you notice, that block starts to turn. Okay, so let's back that up a little. Okay, so first it was standing, and then it gets hit. Okay, and then it starts to turn. Okay, so what you'll need to do here is first you're going to find the linear velocity and linear momentum of the marble. Okay, then you'll find the final, or after the collision, linear velocity and linear momentum of the marble. Okay, then you'll find the linear velocity and momentum of the block, and continue there. Okay, so the next part is, so I broke it down in here. It doesn't really provide much information for us, so I went ahead and broke it down to hopefully make more sense of what I want, what we're looking for. The next part is looking at the angular momentum of this collision. So again, we have this idea, okay, and we want to know about the angular momentum now. Okay, and the marble doesn't have any angular momentum, it's just going in one direction. Okay, it's only like in the x-axis, but if you pull this up, okay, if you pull up your like protractor right here, you can see that the block changes direction, right? So it starts to like spin. So it's given some kind of angular momentum. Okay, so you'll just have to kind of follow it to see, okay, it's at this now, or it's at this point now. And you'll just use, you know, your different tools here to determine that angular velocity first, and then momentum. Okay. So it asks what the rotational inertia is, and then the angular velocity. Okay, remember that inertia was, that was also in our PowerPoint, and we can treat this as, let's see, rotational motion. Let me go ahead and bring that slide up here. You can treat that as, I would say, it's a block. Well, it's going that way. Slab about the perpendicular axis through the center. Or this. I would say just treat it as a thin rod. That's what I would say. It would probably be the easiest way to do it. Yeah, that's how I would do it. And let's see if it gives the mass. Yes, it does. The block has a mass of 36.2 grams. So that's how you can find your inertia. Okay. And then you find your angular momentum, and you want to answer a couple more questions, and so forth. Okay, so hopefully this isn't too difficult. There are a lot of questions, it seems like, but I really tried to break these down so they made more sense. Because again, they have a couple of questions, but I wanted to make sure you fully understood them. Okay? All right, so that is for the lab this week. Of course, if you're still stuck, let me know, and I should be able to help.